Good morning, guys. It is Mr. Citro here. Couple things about today's agenda. So first of all, let's just peek at the week here. We're going to continue Unit 9. Today you have a quiz on Castle Learning. It is posted up there. We'll go over the workbook solutions on Wednesday, and then you have a PhET simulation activity. I do want to put in this Google Meeting. Okay, I posted something. I'd like us all to get together from 1:30 to 2 on Thursday. Okay, so please be there for that. I'd like to discuss a couple things. In terms of yesterday's starter, you guys just had to make sure you were getting caught up. And remember, most of this information is right down here in your reference table. So let's take a peek here at how we solve some of these Coulomb's law equations. Now, first thing is Coulomb's law. This equation is very similar to ones that we have done previously, such as gravity, where we had a constant and then two masses and then a distance between the two. This is the same thing. This is essentially just an electric force, okay, Fe, where this should be Fg equals this. This is the gravitational force. So remember that distance plays a huge role, and also mass plays a huge role in this, where distance plays a big role and charge plays a big role. K is constant. That's on the front of your reference table. So initially, this is the electrostatic force, Fe. Okay, they're wondering, if one of the charges is doubled, what's the new force? So we need to just plug everything in and figure out what the change is going to be. So we know Fe, in this case, is 0.08. K is constant, so let's keep that as a 1. One of the charges is doubled, and then the other one remains the same. We see nothing about the distance changing, so this is also going to be a 1. And we're going to square that, which means that the result would be twice the force. And if the original force is 0.08 newtons, we need to double that, which should yield 0.16 newtons. So you're going to do that with all of them. Okay, if we look here, we have two charges for number 2. If the charge of both of them is doubled, what's the new force? Well, we would have 1, 2, 2 in that case, and 1 down here. So this would be 4 times the actual force. Now, distance is going to be down here. Remember that it is squared. So if the separating distance is doubled, what's the new force? So we still have 1s on the top here, because we're not changing anything about the charge. But what we're doing is we're doubling the distance, which is squared, which means your result is 1/4 the original amount. Okay, and if you plug all this information in, here is what we would end up seeing in terms of the answers. Let me know if you guys have any questions. Okay, again, you get quiz. I'm gonna do a couple more starters here on Wednesday. Go over the review book. And then we've got our meeting in a Friday starter. All right, guys. Let me know if you have any questions. All right. Happy Tuesday. Get outside. It's going to be nice today. Get outside, but socially distance yourself. Okay. Lastly, remember the videos are here. Follow through the sections. As I mentioned, some of these further sections, the numbers are a little off. I've changed things around from Mr. Mellon when he initially started this website. I think it's great. I haven't heard any positive or negative comments. I've heard positives, but no negatives about him in his videos. Hopefully it's working really well for you. Do not forget that we have our own physics channel here. Okay, so just make sure that we're paying attention to that. Other than that, I'll load this on right now and let me know if you guys have any questions. All right, that is it for Tuesday.